The setup for lab this week should be looking pretty familiar. In previous labs, we had been observing what happens to a test article that's subjected to mechanical stress. So this lab experiment is going to discuss the topic of creep. So creep is a situation that happens when a material is subjected to mechanical stress for a prolonged period of time, and the stress is below the yield point of the material, which should otherwise not cause permanent deformation once the load is removed. So once the load below that which causes plastic deformation is removed, the part should spring back to the original position. In materials which creep, that spring back, even if the load was less than that would be required for plastically deforming the material, there may still be a permanent deflection that's visible. So a lot of materials exhibit this phenomenon, and it usually happens faster at high temperature or at elevated temperature. So that's important because there are lots of things that operate at high temperature. So what we're going to do for this experiment is we're going to load our test articles into the frame, and our test articles for this lab are two polymer threaded rods, and on one end it's sharpened into a point so that you can use the point as an indicator for keeping track of the deflection of the rod. And for static load, we're going to use these large hex nuts. So the nuts each weigh 52 grams. When you get the one or the other rod loaded into your test fixture, you'll find that one is stiffer than the other. So for the softer of the rods, the gray one, so there's a gray one and a black one, you'll want to get your part loaded into the fixture, keep track or put a mark of where its initial position is. For the weaker of the two rods, we're going to use one nut to apply a continuous load to the end of the fixture, and you're just going to hang the nut near the end of the rod. For the one that's a little bit stronger, go ahead and use two of the nuts near the end of the rod. So this one has displaced something around 6 millimeters from where it started. It started at the second of the large lines. So getting your material loaded in there like that, you're going to use two wing nuts on one side to hold it into one of the angle brackets. If you end up with extra fasteners, just set them aside. We're not going to need any. So what you're going to do to apply an elevated temperature is to categorize creep. You need to keep track of the temperature, the loading or the stress in the part, and the duration of time that it was at that temperature. So you're going to get with a group of a couple people, and the first thing you need to do is you need to enclose all of your test articles in the warmed environment. So we're going to do that by just tenting over a row of some of your parts with a cardboard box. You're going to have a heat source, and you're going to have a way to measure your temperature. So you'll put the thermometer in the enclosure. You'll need to cut out a hole and maybe some vents and do a little problem solving to get heat into the test setup. And the temperature that you need to aim for is to hold the temperature around a steady 45 degrees C or 115 Fahrenheit. We're going to start with an increment of about 10 or 15 minutes at these temperatures. Whatever the exact time is, just keep track of it. This temperature is important because in order to observe creep, you need to be below the melting point of your test article. And for plastics and polymers especially, it's important to have the temperature be below the glass transition temperature of that material. The glass transition temperature is sort of analogous to the melting temperature for some other materials like metals. So you need to not exceed the glass transition temperature. The glass transition temperature for one of these materials is something around 60 C. So you need to not get close to that, because then you're actually melting the part and we're not observing creep anymore. You're observing a different behavior.